imperfect, perfect, as well as redundant. When we call them as imperfect, when m is less than 2j minus 3, then that is considered as imperfect frame. When m is equal to 2j minus 3, that is considered as perfect frame. When m is greater than 2j minus 3, and that is considered as redundant frames. So we have seen coming to this. So if m is less than 2j minus 3, then that is called as unstable structure. When m is equal to 2j minus 3, and this will be referred as stable and determinate structure. When m is greater than 2j minus 3, this will be referred as stable structure, but however, it is becoming indeterminate. So here our first topic deals with the analysis of perfect pin jointed frames. So here, to analyze this perfect pin jointed frames, we have different methods that are available with us. Method of joints, method of sections, tension coefficient method. So what is meant by analysis? Here analysis is nothing but calculating the force in the member as well as what is the nature of the force. Here, for example, see this truss that is given to you. This is called as a frame or a truss. You can observe where you will see these types of trusses. So I will show you a diagram just to see. You might have seen a steel structure which is supporting our workshop. You can see in your first year you might have seen our workshop or a shed which is having a structure like this. So here the members are connected together like this, and they will be connecting like this. So this is nothing but our truss. So this truss will be internally having certain members will be there like this. Now, what we are calculating is if a load is coming, how the load is coming? From the roof, the load is coming to the truss. So this will be acting at the node points. These are called as node points. It will be acting a load that I'm representing the load like this. Now, due to the application of this load, what is the force that is there in the member? Now, understand here, in the pin jointed frame, when I call it as a pin jointed frame, the nature of the pin jointed frame is it will be subjected to only axial forces. So, pin jointed frame, the members in the pin jointed frame in pin jointed frame are subjected to axial forces only. So these axial forces, one is compression, second one is tension. So the force is considered as axial. It will not be subjected to any bending moment. It will not be subjected to any shear force. So these pin jointed frames are subjected to only compression and tension. That's it. There is no other force that is acting on this. Now to analyze these pin jointed perfect frames, we are taking the help of three methods. One such method is method of joints. So all of you please keep a heading method of joints. So we will first of all understand what is the procedure that is followed in this method of joints to analyze any pin jointed perfect frame. So the first one is write down the method of joints The member forces are determined using the equilibrium conditions, at that particular joint, using the equilibrium conditions at that particular joint. Now understand here, the number of equilibrium equations that are available for a particular joint we need to understand. So here the available equations of equilibrium, the available equations of equilibrium at a pin joint are sigma fx is equal to 0, sigma fy is equal to 0. Now understand here, in a plane structure, two-dimensional structure, we know that the available equations of equilibrium are three. That is sigma fx is equal to 0, sigma fy is equal to 0, sigma m above any point is equal to 0. Whereas here I am saying here the available equations of equilibrium are two only. Why? Why I am saying this is a two only? Because the thing what is happening is we already discussed here at a pin joint there will be no moment. The members, they will be subjected to axial forces only. So as they are subjected to axial forces, inside the members, the bending moments are zero. That's why if you consider here the available equations of equilibrium at a pin joint are, they are two. Is sigma fx is equal to 0, sigma fy is equal to 0. The procedure is as follows. Right on the first point. Procedure is as follows. So, note on the first point, check the stability. First point is whether the given frame is pin jointed for a perfect frame or not, you have to understand. And we have to see what is the determinacy. So, check the stability. First point is check the stability and access the determinacy of truss. Check the stability and access the determinacy of the truss, whether the given truss is determinate or indeterminate. Here, the method of joints can analyze the frame when it is determinate. Whether it is stable and determinate, then only you can analyze. Otherwise, you can't analyze the structure. That is a point. Second point, if the truss is of cantilever type, if the truss is of cantilever type, that is how it looks like is, for example, a truss is there like this. This type of trusses will also be there to support, for example, a portico is there. At a portico, I would like to provide a truss. So this is a type of a truss that is provided. So it looks like this portion is fixed at this one, and the remaining portion is at the other end. So this type of truss or a frame, we call it as cantilever type. And the loading will be like this. Here the load is coming, or the load can also be here acting like this. reactions need not be computed. Well, determine reactions of the support. Determine the reactions of the support. So the first point is, first of all, check whether the stable structure is stable or not. The second point is see that the structure is not facing like here, if it is a cantilever, then no need to calculate any reactions. If it is a simple supported truss, then determine the reactions of the support. Third one, draw the free body diagrams at each joint and analyze the member forces analyze the member forces at the joint where only two member forces so just understand here the meaning is draw the free body diagram at each joint and analyze the member forces at a joint where only two member forces meet. So I will tell you here why we have to consider the member forces at a joint only two member forces are to be meted. I will tell you this one, just note this point. This process is repeated until the analysis of all joints is computed. Analysis of all joints is computed. The forces are tensile. The forces are tensile if they are pulling away from the joint. Pulling away from the joint. Consider tension as positive. That means see here, for example, this is a joint here. Two members are meeting at here. For example, this is considered as away from the joint is considered as tension. And this force will be considered as positive. The sign given for the tensile forces is positive. The forces are compressive. If they are pulling towards the joint. For example, a joint is here And if the force is coming towards the joint, then this will be considered as compressive, and the compressive force will be considered as negative. So this is the assumption that we have to consider. In some of the textbooks, compression will be considered as positive, tension will be considered as negative. However, here you can see compression can be considered as negative, tension can be considered as positive, right? If you have written this, the 4 points, now we will go to the problem and we will see how to solve a problem, a given truss using method of joints. There I will once again explain these 4 points. If you have completed, please respond.
Completed, sir.
I want the response from your side in the chat box. So first one is in the method of joints. We are seeing that the problem. First one is we have to check the stability of the structure, and after considering the stability, whether it is pin jointed perfect frame or not. If it is perfect frame, then we will start analyzing the problem. So in the pin jointed perfect frame, we have to see whether it is a cantilever or simple support. If it is cantilever, so no need to calculate any reactions. If it is a simple supported truss, so for the simple supported truss, you calculate what are the uh, reactions of the support. Then we have to consider the free body diagram, where we need to consider the free body diagram where the unknown forces are 2. The meaning is where the unknown forces are 2 or less than 2. Why we need to consider, for example, uh, at a joint there are 3 members are meeting. So can't I take that free body diagram there? I will see that. I will explain you that. So, to analyze this, first of all, we will go with one problem. Note on the problem. Determine magnitude and nature of forces in all the members of the pin jointed perfect frames using method of joints. In general, it will be specified by which method you need to solve the problem. Otherwise, you can choose any of the method to analyze the member forces. So it is mentioned as using method of joints, you need to calculate what is the force that is there in each member, right? So not on the problem. And here one thing you need to understand, these points we can wherever the members are meeting. Here the members are, here this is B. A, B. Don't consider A and C as a single member. No, like that they will not be there. A, B is one member, B, C is another member. AB is one member, BC is another member. Here at A, B, and C, there are the forces that are acting here. This is D. So now, first of all, we need to understand whether the given frame is perfect frame or not. That is a point that we need to first of all understand. So can you tell me here how many members are there? How many members are there here?
7 members, sir.
1, 2, 3, 4, 5, 6, 7. The total 7 members are available. How many joints are there? 1, 2, 3, 4, 5. Total 5 joints are there. So the number of joints are 5. The number of members are 7. We know that 2j minus 3, that is nothing but 2 into 5 minus 3, which is 7. So 10 minus 3 is 7. So M is equal to 2j minus 3. So what we have checked here, first of all, check the stability. Yes, the structure is stable and it is determinate. So now, the given frame is a pin jointed perfect frame. It is actually to be considered as a simple supported truss. So first that one you calibrate the reactions of this. So we need to calculate the reactions. In the second step, calculation of reactions. So get that one. Calculation the reactions. Now what are the reactions here? This is a roller support at E. A roller support, the reactions will be, this is the vertical reaction. This roller support is not like this. So this is like this. So the reaction here it is RE. I'm not writing REX and REY. Why? Because here it is RE only. Why? Because only in X direction the reaction is there. There is no force along Y direction. Whereas coming to A is a hinged support. So here the reactions are RAX as well as I can also consider here another force, vertical force RAY. So if you draw the free body diagram here, calculate the reactions. So it looks like this. This is our frame. This frame this is RAX, this is RAY, this is RE, this is 25 kilonewtons, 25 kilonewtons. This is 4 meters, this is 4 meters, this is 6 meters. Now, using your, for the calculation of the reactions, sigma Fx is equal to 0. When I write sigma Fx is equal to 0, summation of the forces, what are the forces along horizontal direction? Rax plus Re is equal to 0. Rax plus Re is equal to 0. Sigma Fy is equal to 0. Summation of the forces along y direction. Ray is going in the upward direction positive, minus 25, minus 50, minus 25, which is equal to 0. That implies Ray is equal to. Please remember, whenever you write the value, along with that value, the units are very important. So this is Ray is equal to. Now take moment about A. Sigma m about A is equal to 0. So when sigma m about A is equal to 0, That is, clockwise will be considered positive, anti-clockwise will be considered negative. So you are taking moment about this point. RAX will not come, RAY will not come, 25 kilometers will not come. Why? Because I am taking moment about A. That is force, moment is nothing but force distance. 66.66 kilometers is RE value. Now you know that from sigma fx is equal to 0, RAX is nothing but minus 66.66 kilometers. That's it. So step 2 is that one. Now we need to go for next step is considering the free body diagram. So considering the free body diagram means in step 3 we need to consider free body diagram at joints. Consider free body diagram at joints. So which joint I need to consider? In this entire thing, just go to your problem. A, B, C, D, E. Where you need to consider your joint. Shall I need to consider my free body diagram at A, at B, at C, at E, or at D? Just understand here. So to start your problem, where you need to consider. Shall I consider at A? Shall I consider at B, at C, at D, or E? The guidelines given as per method of joints is wherever you are drawing the free body diagram, there the number of member unknown forces should not be more than or equal to 2. Should not be more than or equal to 2. That means that if I consider free body diagram at A, how many member forces are available at A? AE is one member force, AD is another member force, AB is another member force. So three members are meeting at this point. When three members are meeting at this point, then you need to get when three member forces are there. So here, okay, if I go with B, how many member forces are meeting at B? BA is there, BC is there, BD is there. Three member forces are there. At these three member forces, so just understand the meaning is nothing but the unknown forces should be equal to 2 or less than 2. Whereas coming to C, how many member forces are there? BC is there, CD is there. Only 2 member forces are there. Yes. Now I can start my problem with considering C as like the first joint where I can draw the free body diagram. So just go to the free body diagram at C. F, E, D, at C. So if you draw the free body diagram at C, what does it mean? Represent the members with forces. So this is like this, this is like this. This force is nothing but force in BC. This is your C. Whereas this is force in CD. And here a load is acting which is 25 kilonewtons. Just see your question. Just you are cutting this, just here you will cut a section here, and here the force, that means the members will be replaced with the forces, force in BC, force in CD, and here a 25 kilometers is acting. Now we should know what is the angle here that is made. What is the angle? How can I calculate the angle here? Here this is 6 meters, total length is 8 meters. If I call it as theta, I can consider it as tan theta. Why? Because opposite side by adjacent side, tan theta is 6 by 8. So theta is nothing but tan inverse of 6 by 8. So the theta angle is 36.86 degrees. represent the same thing in your free body diagram also. Yeah, we are running out of time here. Now the time is 11 o'clock. Let me stop here. Let me take the attendance. I will continue this problem in the next class.